presentation. The last speaker is Jennifer Stevenson. Her talk is about the outdoor vectors contributing to residual transmission in Zambia.
Okay, thank you, everyone. As I said, I'm working with Matcha Research Trust and Johns Hopkins. I'm going to be presenting some data from our site in Zambia when the presentation comes up. The data that I'll be presenting today falls under one of the International Centers of Excellence in Malaria Research. And we work in two transmission settings, and this is data from our southern site, which is an area targeted for malaria elimination. I'm preaching to the choir here on this slide. As we know, a lot of cases of malaria over the last 15 years have been reduced, and a lot of that is attributed to indoor control. And this is because historically in the past mosquitoes have been shown to bite in the middle of the night. And the data on the right there shows data from Zambia looking at Anopheles funestus that still bite mainly indoors in the middle of the night with different interventions that have been rolled out. And the majority of the population are asleep during the times of activity, so bed nets and IRS still work well in that area. However, we also know that malaria persists despite high coverage, and this data from West Africa actually shows a change in mosquito behavior over time as interventions were rolled out. So we find in certain areas that either vectors may change their behavior in response to interventions, or as overall vector numbers are reduced, you start to see vectors which maybe had been ignored or not noticed before as they become more dominant in collections. One of the things when we're looking at vector behavior is also to take into account human behavior. You may find a mosquito that bites outdoors, but if people are not outdoors at those times, then that's not really something to worry about. So in our southern site in Zambia, which is here in southern province, we have had a number of interventions rolled out. There's very high coverage and use of bed nets in the area. There's some limited IRS, and a mass drug administration has been rolled out in some areas, and a reactive case detection strategy is ongoing in the area with the aim to eliminate malaria. And I just wanted to point out what we're talking about here in terms of residual transmission. So this is transmission that still goes on despite high coverage and use of good quality interventions. We feel in this area here we've probably got some gaps in protection still, but also some transmission which may be taking place outside and isn't targeted by current control interventions. And so I want to show you some data which would support that. So as I said, in Choma district, this is an area targeted for malaria elimination. Cases of malaria and pediatric hospitalizations in our area have dramatically reduced over the last 15 years, but cases still exist, and in 2016 there was a blip. Far higher cases we had reported at health facilities within the catchment area of Matcha Mission Hospital than we've seen in the last 8 years. We've been conducting entomological surveillance indoors as part of the ISMA, and in the first 2.5 years or so of surveillance, we showed there to be actually no infected mosquitoes that we were catching indoors. The majority of these vectors here are Anopheles arabiensis, and they have a high preference to feed on people from these indoor collections. What we also noticed is we were collecting a few species indoors which are normally thought to be zoophagic but did have human blood. We started looking at foraging activity, both indoors and outdoors, and arabiensis in this area shows that typical midnight peak, still supporting the continued use and upkeep of bed nets in the area. We tried to get a handle on what was happening outdoors, and from some studies that we did a couple of years ago, we used some barrier screens to collect mosquitoes that were set up between breeding sites and homes, and showed quite a different pattern of activity through the night of arabiensis to what we see indoors. We also observed human behavior within the homesteads at those times and documented the last time that people entered their houses. And we got quite an overlap between human activity and arabiensis activity. we couldn't really say what these mosquitoes were doing. These barriers really just acted as an intercept trap. So we took this a bit further, and earlier this year we conducted a Latin square study really to look at the best ways of sampling mosquitoes, but also the numbers, species compositions, and times of biting in different localities within the homestead. For us to be able to decide where we were going to set these traps, we actually spoke to individuals in the households, observed what they were doing, and where they would congregate and spend time after dusk. So 3 sites were selected. There were these outdoor cooking structures where people cook and gather at night. These are animal shelters here where they tend their cattle in the evenings as they're putting them away. And these are outdoor latrines or washrooms where we set light traps. From this data, the top graphs here show the numbers and species composition. And unlike what we see indoors, we have a high number and proportion of Anopheles squamosus. We still find Anopheles arabiensis outside. And from some of the studies that we were doing of those light traps that were set next to kitchens, we were able to document the activity of mosquitoes through the night and also human activity around these kitchens. And as we'd seen before from the barrier traps, we found a period up until about 10 p.m. at night where there's overlap and exposure of people to mosquitoes. We have now changed our sampling frame in Matcha, and we're piggybacking on the reactive case detection system that's happening there. We now set traps at index case homes and within a certain radius of that index case, and we're finding far higher mosquitoes than we would do from randomized houses. We've now also added a surveillance of adding a light trap to those animal shelters, and again getting far higher numbers of mosquitoes. Now that's not really a surprise. We would expect there to be more Anophelines that are attracted to these mosquitoes. But the interesting thing is we started also looking at sporozoites and everything that we caught. So these are the graphs comparing the indoor collections from these reactive case homes on the left here, and this is outdoors. So you see that the species composition is markedly different throughout the year. And just to point out also that the scales here are very, very different. You had to break the graph here to capture some very mosquito-ish households and also some localities within homes. So these are all set next to animal shelters. And now for the first time in the last 2 years, so this is from 2015 to date, we've started finding some infected mosquitoes. So infected mosquitoes we're finding clustered around index case homes, but we're also finding them outdoors in species that hadn't been incriminated as vectors before. And just to say that these are all CSP positives that are documented here, but we have confirmed a number by qPCR. These are ELISA positives, and all these species here have been identified by PCR, but we're sending them off for sequencing just to confirm these. So this is the comparison between indoor and outdoor traps, just averaged out, and as shown in the previous slide, we were interested in this species, Anopheles squamosus. So knowing that we've got infections in this, we did some phylogenetic analyses, we did some sequencing, and demonstrated that we actually have 2 clades of Anopheles squamosus in this area with infections falling in both. So these infections were by ELISA, but some were also confirmed by qPCR, and we published this work last year. We're now moving outside of the home. This is data that was pulled together by our team in Kelly Cell, who published this this year. This is showing GPS logger data from individuals. So we gave individuals a logger and monitored where they went and where they spent the most time over a large geographic area. So we're able to break down this data and look where people frequent after dusk. And it's in some of these localities that we would like to now start sampling mosquitoes, really to look at those mosquitoes that people are actually being exposed to. So I'm just going to end on a few slides of what we're looking at in Matcha as potential ways to perhaps control mosquitoes in these outdoor localities. We have a semi-field system in Matcha that we built that has a self-replicating colony of Anopheles gambiae SS. And a couple of studies that we've been looking at here. One is the evaluation of a spatial repellent device that can be deployed indoors and outdoors and is showing promising results. There was a poster that was presented in the late breakers earlier this week on that. We hope to have a paper out soon. And then also, as I pointed out, those kitchens that we've got in the area, we've looked at different methods of screening them in the community and also carried out some CAP surveys on people's susceptibility of these. And I'd just like to thank the large team that is involved, and particularly the entomology team at Matcha. So Limonty here is my right-hand man, and him with Twig, Charlton, Alpha and Kyson form our team, and just like to really highlight their contributions, as most of the hard work was done by them. So thank you very much.
Yeah, we have time for questions. Yeah, if there's no question, then we just close this session. And thank you for all the speakers, and thank you all for your attention.